Hi everybody, this is going to be a very quick video because we did this in class. So I'm going to show you the answers that are up already and just explain to you how I got them. Alright, so I have Pokemon here because like the theme says of Pokemon, gotta catch them all. You've got to catch all of these concepts for pre-calculus for your test tomorrow. Alright, moving. First one, remember that the vertical shift, so this is the vertical shift, alright, the 4 is the vertical shift, that is your asymptote. So since the vertical shift is your asymptote, when you move vertically, that's y equals, that's why the asymptote is y equals 4. So it goes right through 4 on the y-axis. Alright, so the domain for exponentials will always be all real numbers, and the range is going to go from asymptote up to infinity. Now these numbers, you always want to try to figure out how do I pick the numbers to replace. Well, if it says x plus 3, you know that you want your first number to be -1. So you can do that, and that will tell you that the first number to put in for x will be -4. So that's one way of figuring out what numbers to pick. And then you pick the next two numbers that come after. So there are your answers for the graph. I put the first one in between -3 and -4. The second one is right at -3, and then the last one is right in between -1 and -2. To make a good, nice little exponential graph. Okay, number 2 was a log graph. Log graphs have vertical asymptotes instead of a horizontal. And the asymptote is based on what's inside the parentheses. So you take what's in the parentheses and set it equal to 0. Which is how I got x equals 0. X equals 0 is a vertical line. So make sure that your line does go down vertically. Now for this, you have to change it. Remember we did this on Monday. You have to change your log to an exponential. So you have to use this form to be able to solve it. Now in this case, when we changed it to an exponential, at first when we first started we had to add 6. And then when we changed it to an exponential, here it was e to the y plus 6. Now again, when you're trying to figure out, well, what numbers am I going to place for y, being that this is a log graph, we start with y, you can always say y plus 6 equals -1. And that -7 is what you will replace here, and then just put the next 3 numbers. Okay, so that's another way of figuring that out. Now, I told you in class today you can leave it as 1 over e. We know that 1 over e is 1 over 2.718. So that's in between 0 and 1 on the x-axis. And then 1, -6 is here, and then 2.718 has to go between 2 and 3. So here are your 3 dots that make your log curve. Always know that your asymptote starts with x, the range is all real numbers, and the domain goes from asymptote to infinity. Alright, so for transformations, you have to remember this. Okay, remember A represents your vertical stretch or your vertical shrink. You're going to stretch if A is greater than 1. You're going to shrink if A is a fraction. If A is negative, that is a reflection over the, it's a reflection over the x-axis. Now the B tells you whether it's growth or decay. We're not really going to do anything with this part. Now the next part here, the H, if the H has a negative in front, then you're moving to the right. If the h has a plus in the front, you're moving to the left. And then the last one, k, that's your vertical shift. And that tells you if you're moving up if it's positive and down if it's negative. Okay, this is your horizontal shift. Alright, so make sure you read exactly what it's saying to see how to change the problem. This is your original, this is your change. Alright, for number 4, you're going to do the same thing. Now remember, the A tells you whether you're reflecting over the x-axis. It also tells you whether it's a vertical stretch or shrink. Also, the H tells you whether you're moving left or right, and the K tells you whether you're moving up or down. But also, you have to remember that the X here tells you whether you are reflecting over the y-axis, if it's negative. So that's why here it says reflected over the y-axis. So here's my negative on my x. And then it says stretch vertically, which that would be my A value, by a factor of 2. So that would be your answer to the question. Now someone in 4th period asked if they can put the x on the inside. I said yes, but it's most likely that you should be looking at the first choice. Alright, remember we're talking about expanding and condensing. You have to remember these rules. You have to remember your product rule, which means that if two things are being multiplied, you can split them apart by using a plus. Remember your quotient rule, because this will not be given to you. And that says that if you have things that are being divided, you can split them apart by using subtraction. And then also with expanding and condensing, you have the power rule. And the power rule says that if you have something in the front, or actually it says if you have something that's written as a power, that power can drop down and be a coefficient. So this is called expanding. Okay, this whole section is expanding. And then if you're working backwards, going from here to here, that's condensing. So condensing and expanding. So number 5 was expanding. I have 3 things that are being multiplied, so I should have 3 different terms here being added. Also, because of the power rule, the 6 drops to the front, and there is your expansion. Now the next one is condensing. The first 2 are being added, so that's your product rule, which you should show here as 2 things being multiplied. Now both of these are being divided by the last one, which would be z to the 3rd. Okay, so make sure that you do remember this. Alright, the next one, we have 2 things on the top being multiplied, and then we have 2 things being divided by 2 things on the bottom being multiplied. So here's the multiplication representation there. Here's the multiplication representation there. And then the division is right here. So basically, I've taken my powers and made them coefficients. That's what you do in expansions. Now condensing, this one was an interesting one. You wind up having 3 over 36 over x to the 5th power. Now remember last semester, or maybe even last month, we talked about the fact that you can't divide a fraction over a fraction. So the rule for that would be to change the fraction bar to multiplication, and then to write the reciprocal of the denominator. So that means that if I change this fraction bar to multiplication, that becomes that. The top stays the same. This should be refreshing your memory. And then the reciprocal of x to the fifth is 1 over x to the fifth. Meaning if I multiply across, I get 3 over 36x to the fifth, which is why that's my answer. Alright, these you just should know your powers. 3 to the third is 27 because it's a fraction, it's negative 3. Log of 10 means count your zeros, so we have 1 0, that's 1. I have the explanation here for number 11. This is just 7 to the third power. If you don't know, you can write it out like this. And then just keep multiplying 7 until you get 343. So because we had to multiply 7 3 times, that's why the answer is 3. Okay, here's the explanation here for number 13, and number 14 is the same thing as number 12. So just ponder on that for a second. Alright, equations. So first thing you should do is solve them algebraically. Just try to get rid of things. So we have minus 5 here. Then I'm going to divide by 2. Don't do the power rule. Don't do it because it's just going to get complicated. So just do regular old school algebra. And then when you get to this point here, that's when the pre-cal comes in with changing from log to exponential. Now I wrote I think on the second page for the second question, I wrote what the change is, but I will write it again just in case you don't want to go back. But this is log to exponential. But you know you can always go back and do exponential to log for some questions. So we went from log to exponential, so 5 to the fifth equals 4x minus 9, and then just solve algebraically using a two-step equation. Number 16, you do the same thing you did for number 15. Divide by 6. You get log base 4 equals x squared plus 5 equals 1. 4 to the 1 equals x squared plus 5. You can minus 4 from both sides, or you can move the 4 over to factor. But you get x squared plus 1 equals 0. You cannot factor this. So you do minus 1, and you see that we have a negative 1. This is not a real solution, and everything we've been working on for these two units are based on real values. So don't put x equals plus or minus I, because we're not working with imaginary right now. Just leave it as no real solution. But I don't know if we'll have that question tomorrow. Alright, the next one you had a 1/3 in the front, and I wanted to get rid of 1/3. The way to do that is to multiply both sides by 3, which is called the reciprocal. So now here we're left with 2 to the x minus 3 equals 18. So now you have to go from exponential to log. Okay, go to the page before this one to see what it should look like. So your base stays the same. Switch these two places. So 18 goes to the left, x minus 3 goes to the right. Add 3 on both sides, and here you have log base 2 18 plus 3 equals x. This is how you put it in your calculator. You put log of 18 divided by log of 2, close your parentheses, and then do plus 3, and it will shoot out 7.1699, and I just rounded up. Now the change of base formula is when you have log of a base x would be log of x over the log of b. This is called the change of base. So that's why I wrote this like this. Alright, next we have 18, so you should have added 6 on both sides and got 22. Divided by 8 on both sides, and then you get 22 over 8. 22 over 8 is divisible by 2, and that's how I got 11 over 4. Try not to do decimals until the very end. So then you have 1/2 to the x plus 4 equals 11 over 4. For this section now, you're going to have to do exponential to log. So it'll be log base 1/2, so notice the bases stay the same. And you switch places with 11 over 4 and x plus 4. Minus 4 on both sides. And put it in your calculator using change of base. So you're going to put log 11 over 4 divided by log of 1/2 and then minus 4. And that's how you'll get this answer here. Alright, the next one you did have to use the product rule, and the reason why we used the product rule is because you have a plus in the middle. None of the other problems that we've had a plus in the middle of 2 logs. So when you have a plus in the middle of 2 logs, you use the product rule. So it means you're going to multiply x plus 5 times x plus 4 using FOIL, which is how we got x squared plus x minus 20. Now on the other side we have 2x plus 4. You have logs on both sides, so you can cancel those out, and then you could just move things over so that you can factor. Once you factor, you have x minus 3 and x plus 2, and your answers that you get are x equals 3 and x equals negative 2. But here's what happens. When you check I'm not even going to do the other side, because once you see here, log of 3 plus 5 is log of 8. And then you have 3 minus 4, which is log of negative 1. You can't have a negative log. That's a no-no. You can't have this. Nobody's saying you can't have negative answers, you just can't have negative logs. And that's why we had to cancel the 3 out, even though it was a positive number. So now, if I were to check the 2, negative 2, I wind up getting log of 3, which is fine, plus log of negative 6. I'm not allowed to have a negative log. Okay, I just can't do it. So both of them cancel out. On the other side, we have 2x minus 5 minus 3. Since they both have the same log, you're going to use the quotient formula. And the quotient rule is right here. So we have 2x minus 5 over 3. Now, normally on the other side, we were able to just put these two together because they both had the same log. Here, there's a log here, but on this side, there's no log. So you have to carefully look for that. So since there was no log, you're going to have to do the log to exponential rule. So 4 to the second power equals 2x minus 5. 4 to the second is equal to 16. So you're going to cross multiply. 16 times 3, which is 48. 2x minus 5 times 1, which is 2x minus 5. And now just do simple two-step equation and you get 26.5. Alright, this next one, I remember I told you don't use the product rule. So you're going to divide by 2, get rid of that 2 so that the log is by itself. Now you're going to go from log to exponential. So x to the 5th equals 5. The only way to get rid of this 5th power is to do the 5th root. So you can use the fifth root in your calculator of 5, or you can do 5 to the 1/5, but both of them will give you the same answer, which is 1.38. Alright, last but not least in the equation section, you want to get the log by itself. When I say log by itself, I mean you want to get this whole thing by itself. So you want to get this whole piece by itself, which is log with the base and the number next to the base. So first thing you want to do is add 6, gives you 16, divide by 8, so that you can get 2. Now you're going to go from log to exponential. So we have x to the second power equals 1/4. Take the square root, since that's the only way to get rid of the square. So to get rid of a square, you do the square root. And you get plus or minus 1/2. Remember, all even roots have 2 answers when you have to physically draw the root to get the answer. So that's why it's plus or minus 1/2. And both of them will work out fine. Alright, that concludes the equations. I hope that you're fine with that. Now let's move on to the word problems. So Ethan deposits $1,000 in an account that compounds quarterly. Once you see that quarterly, you know that you have to use this formula. So P represents your initial amount, your starting amount. So that's why we put 1,000 there. R is the rate. So you're going to take that rate and move it over 2 decimal places. So that's why it's 0.057. The 4 represents how many times a year. Remember, quarterly represents 4 times a year. So that's why this is 4, meaning that this is 4 out here. The other 4 comes from the problem itself that says 4 years. So that means that this could easily equal 16. So you could have raised it in your calculator to the 16th power. So now just put all this in your calculator just like this, and you find out that the answer is $1,254.07. Always round to dollars and cents, which is called the nearest hundredth. Okay, 24 says compounded continuously. So remember, once you hear the word continuously, it doesn't even matter if it says compounded or not. Once you see the word continuously, that is the PERT formula. So it says, how long will it take for her money to quadruple? Quadruple means to multiply by 4. So that means that you take your 1,100 and multiply it by 4. So we're trying to figure out how long will it take to get $4,400. So that goes in for A. Okay, that's your amount that you're looking for. The P is the starting amount. E, the rate is 0.05 because we move 5 over 2 decimal places. And we don't know what the T is. So first step is divide, and you get 4. Then the next step is going to be to go from exponential to log. So that means E is still your base. So log base E, and you just switch the places of 4 and 0.5t. Once you write your log E, you can change it to ln, which is what I did here. Because your calculator doesn't have log base E, it has ln. So I changed log base E to ln 4, divide both sides by 0.05, and that's how I get 27.726 years. Remember, I am a stickler for 3 decimal places. Don't make me take off points. Okay, next one says that at the beginning of 2005, we had a house that started at $400,000. So there you go with P. and it has decreased. Once you see decrease, you're going to change this plus in this formula to minus. And then it says that it's at 3.4% per year. So I'm going to move this over 2 decimal places, and that's how I get 0.034. Now, a year means that how many times a year is that? That's only once. So that's why I have a 1 here. So you notice I crossed out the 1 because I don't really need it. So this would be, if I wanted to put in my calculator, 400,000, 1 minus 0.034 to the 7th power. And that's how I get this answer. Now if you left the 1 there, you still would get the same answer. Remember, you always need your answers in dollars and cents. Okay, 26 says the population, blah, blah, blah. It says, what is the initial population in 2012? The initial is always the P. It's the starting. So since it starts with 1,500, that's your initial. So anytime they ask for initial, make sure you put that down. What is the rate of growth that is occurring? So the rate of growth, it was at 0.07. This is when you move it over 2 decimal places to the right, and that's how we get 7%. Alright, now this last part says, what's the population in 2020? Now you know that 2020 is 8 years after 2012. So you're just going to do 1,500 e to the 0.07 times 8. Put it all in your calculator like that. And then you get 2,626, and there are decimals afterwards. Remember, no decimals for people. You can put decimals for time. We do have chunks of time, but you don't have chunks of people. So don't put decimals for people. Okay, last one is, at what time t will the population be 4,500? This is the exact same question that was, I think, 24. Same thing, no different. So you're going to replace 4,500. So if this is your equation, the P of t becomes 4,500. 1,500 stays the same, 0.07 and t stay the same because we don't know what t is. First, start to divide both sides by 1,500, and you realize that this is asking when will it triple. Okay, so then you have to go from exponential to log. So we have log base e, because it's the same base, and then just switch these 2 places. 3 goes next to the log, and 0.07t comes after the equal sign. And now I'm going to change my log e to ln, because remember, your calculator does not have a log e button, but it has a ln button. So you do ln in your calculator. You're going to put in ln 3 divided by 0.07, and that will give you your value for t. And your t wound up being 15.694 years. So it'll take a little over 15 years for the population to triple. Alright, that concludes the video. I hope that helped. I'm going to leave a blank copy of the review on there for you so that you can practice while the video is going on. Also, here are your homework questions, because I did say that watching the video is homework. Okay, the homework questions are as follows. Number 1, if you watch American Idol, if not, you can go on Google. Jessica Sanchez sang a song on Friday. Oh, not Friday. Sang a song on Wednesday. What was the name of the song? And who was the original artist? And I am very, very big on original artist. There is someone who made it famous, but that person was not the original. So I just gave you a hint there. Okay, that's your first question for homework. And the second question for homework, so I did a little girly question for the girls and everybody else who watches American Idol, and some of you guys watch American Idol too. Now for the sporty people, I want you to name 3 NBA teams in the Eastern Conference. Alright, that should be an easy question. You guys have access to Google. And one more question to see who's paying attention. Alright, where did Misty get her master's? And then you get, you know, a little bonus if you know what I got my master's in. Because that's not on Google. So anyway, those are your 3 homework questions. If you can write down the answers to those questions yourself, then I know that you watched a video. If you share these answers with somebody else, and I know they didn't watch the video, it will show in their grade. Ha ha. Alright, well, good luck everybody, and I hope you enjoyed this video.